Dear students, in this lecture we will focus on the heat transfer journal introduction. Right, what is meant by heat and how it is transferred. The main objective is to learn about the heat transfer. After the completion of this lecture, you will be able to learn about the heat transfer. Basically, heat is a form of energy which is symbolized by capital Q, and it is the total amount of energy, both kinetic and potential energy, possessed by the molecule in a piece of matter. As it is clear from the definition that the total amount of energy which will be possessed by a molecule and piece of matter will be termed as heat. Remember that the combination of both kinetic and potential energy, that is the total amount, will be termed as heat. Heat is measured in units joules, while on the other hand temperature, which is represented by symbol capital T, is not energy. It relates to the average kinetic energy of microscopic motion of a single particle in the system per degree of freedom. The main difference between the heat and temperature is that heat is energy while the temperature is not energy, and heat is the total amount of energy, both kinetic and potential energy, while temperature is the average kinetic energy of a single particle. And the other differences include that the symbol for heat we use capital Q, and for temperature we use capital T, and for measurement units used for the heat, that is joules, while the units in which the temperature is measured, including Kelvin, Celsius scale, or the Fahrenheit. Now, what will happen when we heat a substance? Suppose we are having a container containing water, and we want to heat up water in that particular container. Then there will be chances of two things to be happen. The first one is either the temperature of that particular container containing water will be rising, or the water in the container will be converted into the vapor state, that is the liquid phase is converted into the gaseous phase if the boiling point achieved. But before the boiling point, the temperature of that particular container containing water will be rising. So whenever we heat a substance, either of two things can happen. Either the temperature of the substance can rise, that I have exemplified the liquid water, or the state of substance can change, that is the liquid water started converting into the vapor state after reaching the boiling point. Remember that if we consistently and regularly heating that particular container. The same case with the water that is in the liquid state, if the temperature is been dropped from the, on the other hand, then it is frozen, that is in the refrigerator the liquid is started converting into the frozen state, that is the solid state of that particular water. Similarly, when we heat ice, that is a solid state, it will melt, converting into liquid after heating. Similarly, when we heat water above boiling point, it is converted into vapor. That's why we say that Either of two things can happen whenever we heat a substance. The first case is the temperature of the substance can rise. The second case is the state or phase of the substance can change. Now this is the differences or comparison chart of the heat and temperature, the definition, symbol, the units, SI units. Remember that the SI unit for the heat is joule while for the temperature is Kelvin. The particle position in the heat is a measure of how many atoms there are in a substance multiplied by how much energy each atom possesses. While on the other hand, temperature is related to how fast the atoms within a substance are moving. The temperature of an object is like the water level. It determines the direction in which heat will flow. The basic effect of heat transfer is that the particles of one substance collide with the particles of another substance due to the molecular motion or movement. The more energetic substance that having a high energy will typically lose internal energy and that is cooled down, while the less energetic substance which initially have low energy will gain internal energy, that is heat up of that particular low energetic substance. Dear students, remember that heat transfer and you are all of several kinds of phenomena considered as mechanisms that convey energy and entropy from one location to another location. By heat transfer, the energy transfer from one area to another area or one location to another location. The specific mechanism or ways are usually referred to as convection, thermal radiation and conduction. These are the different mechanisms or ways or methods of the heat transfer. Heat flows across temperature difference. One thing that is necessary, that is the temperature differences for the heat flow or heat transfer. There are three modes that I have told you earlier, that heat transfer can be possible by three modes or three methods or ways, including conduction, radiation and convection. Radiation is a transfer of thermal energy in the form of electromagnetic waves emitted by atomic or subatomic agitation at the surface of body. That is about the radiation. Heat transfer is a physical process involving the transfer of heat from hot area to cold area. That's why we say that for heat transfer, temperature differential is necessary. So by this way, that is a physical process, that is a definition of the heat transfer, that's involving the transfer of heat from hot area to the cold area. Heat transfer is a process of transfer of heat from high temperature system to a low temperature system, and heat is a form of energy that is transferred between systems or objects with different temperature. Temperature differential is necessary for the transfer of heat energy. That's why we say that flowing from the high temperature system to the low temperature system, also referred to as heat energy or thermal energy. Moreover, heat is typically measured in BTU, that is British thermal unit, calories or joule. These are the other measurement units in which heat can be measured. One of the laws that we will discuss later on as well in this chapter of the heat transfer in the coming class, that the Fourier Law, that is the governing law for heat of conduction process. It states that the rate of heat conduction through a plane layer is proportional to the temperature gradient. Temperature differential equals the layer and the heat transfer area of the layer. Similarly, one of the radiation, that is the heating of the earth by the sun, is an example of transfer of heat energy transfer by the process of radiation, which is one of the way of the methods of the heat transfer, that is radiation. Heat transfer is the process of the movement of energy due to temperature difference. You can consult different books stored in the Blackman, Cooper and Gunn as well for the heat transfer.